let us see the definition for the convergence. So a sequence xn is said to be, in real number, said to be converged to the number x, or we can say is said to be the limit point of the sequence. So when the sequence converges to that number is said to be the limit of that sequence. So it is nothing but a limit. Okay, so if for every epsilon greater than 0 there exists a natural number k epsilon, that is the natural number depends on that epsilon, that is nothing but just a notation. Okay, such that for all n greater than or equal to k epsilon, the terms xn satisfy xn minus x is lesser than epsilon. So this definition is similar, we have already saw this one. So the convergence means it has a limit point. So no, not a limit point, limit. Okay, convergence means it has a limit. So if a sequence has a limit, we say that the sequence is convergent, and if it has no limit, we say that the sequence is divergent. So this is simple. So you can follow this definition. Let's go and solve this theorem. So this states that even Vn to convergent sequence, this algebraic properties holds. That is, sum of two sequences converges to u plus v. Then scalar multiple holds. Then product holds. Then division also holds. But provided Vn is a sequence of non-zero real number and v is not equal to 0. So it means that Vn should not take 0 in any time. Like it cannot be 0 at all for every n. Okay, so this one we are going to prove. So convergence means sequence has limit. Okay, so now we are going to see this theorem. The convergent sequence is bounded. So I'm not going to prove this because this is very simple. Hint is nothing very hint is using a convergent definition, obviously, that is f of n minus l is lesser than epsilon for all n greater than or equal to. So I can write for all n greater than or equal to n naught. Okay, so this is the convergent definition. Maybe I can write everything for all epsilon greater than 0 there exists n naught in n, such that this is the convergent definition. So by using this, I have written it as n is greater than or equal to n naught, right? So after that n naught stages, it is bounded. So for bounded, I have to say, bounded definition also I will write. Bounded, I have to say f of n is lesser than some m. So this m is the hint. The very important part is choosing m. M should be the maximum of I can take maximum of, since after n naught stages it is bounded, so I can take 1, 2 till n naught minus 1. I think it is n naught minus 1, and then so this is obviously maximum. No, actually this is wrong, because we have to say f of 1, because that is what the boundedness property says. That is, the image value should be lesser than m, right? So f of 1, f of 2, till f of n naught minus 1, and then I have n plus 1, that is epsilon. Okay, so see, I will just prove it over here. So f of 1, f of 2, f of n naught minus 1. So up to this we don't know. So it can be somewhere, it can be maximum. Like the sequence can go over here, then comes over down, and then goes like this. So we have to consider this also. So I'm just taking f of 1, f of 2 till f of n naught minus 1. So after this stage only it is bounded by epsilon. So epsilon plus l. This is what my m. So if I'm taking like this, then my sequence becomes bounded. My convergent sequence becomes bounded. Okay, that's the theorem. Now we are going to prove the last part, because that is the trickiest part, and for this I'm going to write the hint over here. Okay, So the hint will be obviously using the convergence. So if there is a necessity for proving these things, I will prove, but if it is not, then we can skip the proof because it will be simple. So here first one, un plus vn converges to u plus v. Okay, so how we can prove? Very simple. Un plus vn, the ultimate aim is to provide un vn minus uv is lesser than epsilon. I'm sorry, this is plus, right? I was doing for this, sorry. So u plus v, so un plus vn should be minus u plus v is less than epsilon for all n greater than or equal to n naught. I think you are clear with this. That is, we have not just now we have seen that if it is convergent for all epsilon greater than 0, there exists n naught for all n greater than or equal to n naught. That is trivially it should be there. So un plus vn minus u plus v is less than epsilon is the ultimate aim. Okay, so you will be obviously knowing that that is you can split this, that is un minus u plus vn minus v, and since un is convergent, vn is convergent, it will be like un minus v, u is less than epsilon by 2, so when you are adding you will be getting plus epsilon. So if you want, you can ask me, I can prove it, but it is simple only. I'm going to prove this and all. So c into un, okay, c into un minus cu is less than epsilon. Okay, this is what we have to prove. For proving this, I think I can prove, because here the most trickiest part is, since un is convergent, they are taking un minus u is lesser than epsilon by mod c. Since un is convergent, this is one hint and this is second hint. So un minus u is less than epsilon by c. Since un is convergent, if it is convergence, if it is less than epsilon, it is also less than epsilon by mod c. So mod c will come here, so it will go inside, and hence we have arrived at less than epsilon. So that is what hint for this question, for this particular point. Okay. So next one will be multiplication, product. So ultimate aim is un vn minus uv is less than epsilon. So for this hint will be, so it is first hint. So second hint will be adding and subtracting. So inside this itself you have to add and subtract u and v. So maybe I can do this one, but I'll just write hint and then I will do. Okay, so u and v will be there. So if I'm going to take so I have to take the maximum of those two things, and I have to prove something more. Here also choosing this epsilon for the un and vn is the matter. That is epsilon by 2b. If you are choosing, then it will be fine. So I'll prove this also, don't worry. Here the hint will be, first hint is 1 by vn minus 1 by v, aim is this one, okay, less than epsilon. Then use product of, that is property number 3, third property, to prove un times 1 by vn converges to uv. So this is by property this, and in between you are going to use the second property also. So this will be the ultimate hint and all. So we will prove this third and fourth alone. Going to prove the third property, that is un plus vn minus uv is less than epsilon. I have to bring. So for this I'm just going to add and subtract these two things. So I'm going to club the first and fourth one, and second and third. So I'm just clubbing, and un will be get common, and here v will be the common term. So using the property, I'm just going to take the modulus out. So that is modulus of a plus b is less than or equal to mod a plus mod b. And then, so this is what happened. So I'm just writing here over here, mod a plus b is less than or equal to mod a plus mod b. You know this, and the mod ab is actually equal to a into b. So that is why here it will be. Okay, fine. So I'm going to take vn is converges, un is convergent, but there is a term in the front. Okay, so I'm going to take the maximum of un and v. So that is why how I can take maximum of un is a sequence. I cannot able to take just like that because it is a convergent. So since un is convergent, this is very important. If you are not writing it is okay, but you have to know how you can take this, because it is a number, you can take maximum, but how you can take the maximum of a sequence? But you can take, because it is a convergent, it is bounded, therefore bounded by some other element, so that element you can, like, it will be the maximum. So b, I'm just denoting b for that. So I have vn is convergent, right? So vn converges to, like, let this epsilon be epsilon by 2b. Since for all epsilon it is true, I can take this. I have chosen this way. Similarly, un minus v is lesser than epsilon by 2b. Since Bn is convergent since Un is convergent. Okay, so there will be for all n greater than equal to k1, for all n greater than equal to k2. I have to take the maximum of those also, like k is equal to maximum of k1 comma k2. So the k1 came from here, k2 came from here, so I will write all this also. Okay, sorry, for all k1 greater than equal to for all n greater than equal to k1, for all n greater than equal to k2, for all n greater than equal to k1, for all n greater than equal to k2, un and bn convergent. So this one is obviously true. So now I'm going to say that my LHS is this one, which is equal to b times epsilon by 2b plus b times epsilon by 2b for all n greater than or equal to k. Okay, so now I have proved un vn minus uv is actually there is a less than or equal to symbol, which is lesser than epsilon. Thus I have proved. Okay, I hope you understand. So now we will see this proof. This requires a constructions. So limit un by vn converges to u by v. When un converges to u and vn converges to v, this is what we are going to prove. So for proving this, I am going to use an idea called un times 1 by vn converges to u dot 1 by v. So this is what I have to prove. Okay, let's prove this one. Un by vn converges to u by v. Okay, when un and vn are converges. So here I am going to use the product rule, that is un is convergent, 1 by vn is convergent, then un product will be convergent. So we know un is convergent. So I am going to take 1 by vn is converges to 1 by v. If I say the theorem, the proof completes. Okay, so 1 by vn converges to 1 by v is my ultimate aim. That is 1 by vn minus 1 by v is less than epsilon. That is we have to show this. Okay. For this the proof starts here. That is I am going to take alpha to be I am constructing this. Okay, alpha to be half times mod v, which implies alpha is obviously greater than 0, because this is positive, product will be positive, hence alpha is greater than 0. So this is obvious. So the proof actually starts over here. So my I know is limit n tends to infinity vn converges to v. So vn converges to v, we know. By this I can say vn minus v is lesser than alpha for all n greater than equal to k1. So when I have alpha to be the epsilon, it is actually epsilon. In particular, if I take epsilon to be half times mod v, what happens? It will also satisfy for some after some k1 stage. So I have written in that way. So I have this I can say this inequality holds after the k1th stage. Okay, so I have a property in the modulus that mod vn minus v is less than alpha. I can also write this in terms of this, like mod vn minus mod v, the whole modulus will be less than or equal to this one. Why I am writing this? Because I need mod vn. I am just using this property. So what I am going to do is I am just going to skip this middle part and I am going to take this and this, comparing this with the alpha. I can say mod vn will be bounded by alpha plus mod v and bounded below by minus alpha plus mod v. So if I substitute alpha value, I am getting like this. So I can say I have to have like 1 by mod vn should be lesser than, like I am just reciprocaling it. Okay, so the inequality changes and 1 by mod vn is lesser than 2 by mod v. So this is what we require, because 1 by vn is converges to 1 by v, means 1 by vn minus 1 by e is less than epsilon. That is what we need. So 1 by vn minus 1 by v, which is equal to, if I take LCM, this is what comes, and hence I can say 1 by vn is lesser than 2 by v. So 1 by vn can be replaced by 2 by mod v. So if I put 2 by mod v, this is what comes. Okay, so for this construction alone, I have done all these things, all this alpha and substitution. So 1 by mod vn is lesser than 2 by mod v. So I have substituted over here. This is true for all n greater than or equal to k1, because this is the stage that I have took in the beginning. So now it is okay. But I need 1 by vn minus 1 by v alone will be lesser than epsilon. That is, this one is strictly less than epsilon, not these things. Okay, so I know this is strictly less than epsilon, but I need this quantity to be cancelled out or something. So what I'm going to do is Again, using this Vn is convergent thing. So since Vn is convergent, I have some stage called epsilon greater than 0, that is k2 in n, such that this one happens. So in particular, this epsilon I'm going to take it as mod v square by 2. So I'm just replacing epsilon 1 with mod v square by 2 times epsilon. So if I have this, then I can say 1 by Vn minus 1 by v will be lesser than v square by 2. So if this 2 goes here, mod v square comes here, it will be less than epsilon. So I have told that this is strictly less than epsilon, and hence my theorem completes by taking n is greater than or equal to maximum of k1 comma k2, because I have got two stages. So I have to take the maximum of those stages, and from there this one holds true. So this is what my aim was. So I have proved this. So un is convergent, 1 by vn is convergent, their product is also convergent to 1 by u by v. That's all.